Hi, and welcome to the podcast for Chapter 7. Today we're going to be talking about population samples and sample size. So the main goal from this for this chapter is to give you an idea about what sampling techniques we use and how we are able to sample from our populations, and then break those down into sampling size and all of the practices that go along with that. So, brief overview of what's to come. First off, as researchers, you make choices. And if you haven't figured this out by now, you make a lot of choices. But particularly when it comes time to do a quantitative research study, you make a lot of choices about who to collect your data from, what to collect data about, and ultimately how much data to collect. However, it becomes even more important when we kind of consider how that impacts our study in terms of what our population is and how we go about sampling that population. So, population and sample. When we talk about population, what we're talking about is all of the units, and these can be people or things that possess the attributes of whatever we're interested in. So, this is everyone out there that is representative of it. So, if we're interested in answering research questions about how freshman college students behave in the classroom. Our population is freshman college students, and perhaps freshman college students in the United States, or so on. The sampling frame, however, becomes the subset of those units, and anything that could potentially have a chance to becoming part of that sample. So we might be drawing from a few specific universities or something. And then the sample is the actual subset of the population which become part of the study after we've selected them. So when researchers talk about a sample, what the important thing is here is that sample allows them to make generalizations back to the population. So it would be really unfeasible if we were interested in studying college students in the United States to try to survey every single college student in the United States. It would take a ridiculous amount of time and money and work on analysis, and ultimately wouldn't give us better data than we would get through our normal procedures. Hence, we get a sample, and by studying that sample, a subset of that population, we're then able to gain those same generalizations and say how that entire population might act as a whole. So, defining the population. When it comes time to define your population, you want to choose those dimensions or characteristics of the population that relate back to your hypotheses or research question. Remember, everything that we do really focuses on addressing our hypotheses or research questions. We want to make sure that there is some sort of common characteristic among all of the members of the population. So, like I said, college students. In the United States would be some characteristics, but you might have other things that tie into it as well. Perhaps individuals working in high-risk organizations would be another example, or users of Facebook, and so on and so forth. Then, as a researcher, you must ultimately develop a procedure to ensure that your sampling is representative, and I'm going to address what that means next. All right, so talking about generalizability. So remember, our goal in quantitative research by selecting a sample is having that sample being representative of the larger population of the whole. So when we talk about generalizability, what we're interested here is to what extent or amount our conclusions that we develop from the data that we collect ultimately relates back to that population. So based on the information we get from a single sample, we want to know how reliable that information is to be extended back to its population. We talk about the sample being representative. That happens as a matter of degree, and it's the degree of which all units had the same chance of ultimately being selected to be part of that sample. By having representative sampling methods, that allows us to eliminate selection bias and problems. So having representativeness is something that we can only really assure through actual random sampling. And we'll talk about what that means in a minute. All right, so probability sampling. What probability sampling it gets at is whether or not the probability that any person or unit inside the study could be included in the sample, and that is known and has an equal probability. When probability selection is equal, then the selection is truly random. And this is what we know as random sampling, and I'm going to go into the different types and specifics of that later. But before we drop into that, know that sampling error will always occur, especially when we're dealing with people. All right, so types of probability sampling. A bunch of different types, and I'm just going to try to briefly take you through all the different types of probability sampling to give you an idea. All right, so first, a simple random sample. A simple random sample is a subset of individuals, a sample chosen from a larger set, i.e. the population. Each individual is chosen randomly and entirely by chance, such that each individual has the same probability of being chosen at any stage during the sampling process. And each subset of individuals, sometimes referred to as K in research, has the same probability of being chosen for the sample as any other subset of K individuals. All right, so that's simple random sampling. The next type is systematic sampling. And so systematic sampling is a statistical method involving the selection of people from an ordered sampling frame. The most common form of systematic sampling is what we call the equal probability method, in which every nth element is selected. So we would say that we're going to select every 8th person from the sample. And if we wanted to get 80 people from a sample set, we would just go ahead and select 8 up until the point where we have the number that we need for that. So a quick note on the distinction between a systematic random sample and a simple random sample. So in a simple random sample, one person must take a random sample from a population and not have any order in which one chooses a specific individual. So let's say that you had a school with 1,000 students divided equally into men and women, and you wanted to select 100 of them for further study. You might put all of their names in a hat and then pull 100 of those names out. Not only does each person have an equal chance of being selected, but we can also easily calculate the probability of a given person being chosen. The means by which every student in the school has approximately 1 in 10 chance of being selected using this method. Further, all combinations of 100 students have the same probability of selection. However, in a systematic pattern, if a systematic pattern is introduced into random sampling, it is referred to as a systematic random sample. So for instance, if the student in our school had numbers attached to their names ranging from 1 to 1,000, and we chose at random starting point, so example, say 533, and then pick every 10th name after that to give us our sample of 100, starting with 3 and reaching to 993 in a sense. The technique is similar to cluster sampling, which we'll talk about in a minute, since no other choice of the first unit, since the choice of the first unit will determine the remainder. This is no longer simple random sampling because some combinations of 100 students will have a larger selection probability than others. So for example, if you had like 3, 13, 23, and so on, that has a 1 out of 10 chance of selection, while 1, 2, 3 through 100 could not really mean the same thing probability underneath that method. But nonetheless, the idea there hopefully makes sense. All right, so the next, stratified sampling. Stratified sampling is the method of sampling from a population. In statistical surveys, when subpopulations within an overpopulation vary, it can often be advantageous to sample each subpopulation, sometimes referred to as a stratum, independently. So stratification is the process of dividing members of the population into homogeneous subgroups before sampling. The strata should be mutually exclusive, i.e. every element in the population must be assigned to only one stratum. The strata should also be collectively exhaustive, meaning that no population element can be excluded. Then random or systematic sampling is applied within each stratum, and this often improves the representativeness of the sample by reducing the sampling error. All right, cluster sampling. Cluster sampling is a sampling technique used when natural subgroupings, natural groupings are evident within a statistical population. Is often used in different types of research, but often amongst communication research as well. In this technique, the total population is divided into these groups or clusters, and a sample of the groups is selected. Then the required information is collected from the elements within each subgroup. This may be done for every element in these groups, or a subsample of the elements may be selected within each of these groups. A common motivation for cluster sampling is to reduce the average cost per interview. So if you have a fixed budget or you're working under a grant, this can often allow an increased sample size. Assuming a fixed sample size, the technique also gives more accurate results when most of the variation in the population is within the groups and not between the groups. All right, so now that we've talked about that, let's briefly talk about non-probability sampling. So probability sampling, or random sampling, which we just talked about, we can see that as a sampling technique in which the probability of getting in particular sample can be calculated, and we can ultimately understand that. Non-probability sampling, on the other hand, does not meet this criterion and should be used with caution. Non-probability sampling techniques cannot be used to infer the sample to the general population. So basically any generalizations obtained from non-probability sample must be filtered through one's own knowledge of the topic being studied. Performing non-probability sampling is considerably less expensive than doing probability sampling, but the results also are weak in value. So since it doesn't rely on that random selection, we lose that representativeness, and we're not sure that our techniques are as good. Hence the reason we try to use other techniques when at all possible. And so this is also often used when the researchers desires a specific type of participants that have had some specific experience or abilities to the study. So something hyper-specific might be interesting. All right, so there are a variety of non-probability sampling techniques. So I'm just going to take you through a few here. Know that there are a lot and that you should spend some time going through the Keaton text, looking at the different types of sampling techniques to make sure you're familiar with them through the test. But I'll just go through a bunch. So I guess one of the most common ones is convenience, also known as haphazard or accidental sampling. Here, members of the population are chosen based on their relative ease of access. So to sample, like, say, friends, coworkers, or shoppers at a single mall, all examples of convenience sampling. Another type that we can talk about is, say, snowball sampling. This is where you would go out and sample some respondents and then ask them to go ahead and refer a friend, and that friend refers a friend, and so on. We talk about purposive sampling. In purposive sampling, the researcher chooses a sample based on who they think would be appropriate for the study. This is used primarily when there's a limited number of people that have expertise in the area being researched. There's also what's known as, say, deviant case, and so this is where you get cases that are subsequently different from the dominant pattern, i.e. this is kind of like a special type of purposive sampling I talked about above. Sometimes we do case studies, and in case studies, the research is often limited to one group, often with a very similar characteristic or small size. Sometimes we have ad hoc quotas, and so this is where we will, as researchers, will establish a quota, say we want 65% women, and the researchers are free to choose any respondent they wish as long as that quota is met. And like I said, there's a bunch of different times you should definitely spend some time going through and looking at the different types of non-probability sampling to be familiar with them. I do want to point out that even studies intended to be probability studies sometimes end up being non-probability studies due to unintentional or unavoidable characteristics of the sampling method. So, for example, real world, when we do public opinion polling by private companies, or other organizations that are unable to require a response, a sample can be self-selected rather than random. This often introduces an important type of error, what we call self-selection bias. This error sometimes makes it unlikely that the sample will accurately represent the broader population. Volunteering for the sample may be determined by the characteristics such as submissiveness or availability of respondents. So the samples in such surveys would be treated as non-probability samples of the population, and the validity and estimates of parameters based on them would be unknown. All right, so almost wrapped up here. A couple things. Quick note on sample size. So when we talk about how many people that we need in a sample to allow generalizability or to be enough, there's some interesting things to look at. So first off, sample size really gets at the number of people or units to which you need to collect data. And this is something you should always determine prior to going out and seeking a sample. The idea here is that there's some equations, and I'll talk about those next. You don't really need to know the equations, but understand how this works. You always want to ask more people to participate than you need for your sample size. The reason is that you're going to have response rates that are ultimately lower. So if I need 50 people to take a survey to have enough people, not really sure where that would work, but if I need 50 people to take a survey, I may want to ask 75 or 100 people. That way I'm sure that I can get that 50 that I need. Ultimately, the larger the sample relative to population, the less error or bias you're going to have. Now, there are a variety of statistical equations and proof theories that tell us how big of a sample size we need in relation to the population. If you want to see this table is wider and bigger in the appendix of your text, but just to briefly go over it here. So we know statistically that if we've got a population of 100 people, to be able to generalize that population, we need 80 people. Likewise, if we have a population of 200 people, we need 132. You'll notice as these numbers get high, the additional number of people that we need to generalize to that population is very small. And if you jump this up into the millions and the billions, you can see that the number, I think, rarely goes over, I don't think it ever goes over 1,000. With 1,000 people truly randomly selected, you could generalize to the entire planet, which is powerful statistically and has been proved again and again to be effective if you're able to limit other sources of error inside your study. But in anyways, important to know how these population works and be able to have an idea, and I recommend getting familiar with that table in your appendix to understand how this works. All right, well, that wraps up our conversation about sampling. I want to thank you guys for your time and see you next week.